Welcome everyone to today's video. We are going to uh, study a concept in the chapter of gravitation, which is called gravitational pressure. What does gravitational pressure refer to? It is basically that pressure which exists at some depth, let's say x, within the surface of Earth because of all the weight of the Earth above that point. That is, if we take a thin spherical shell inside Earth, and all the part of Earth that is having higher radius than that particular shell, it will exert its weight on that shell. It produces a gravitational pressure on that point. So, what is that value? What is that gravitational pressure we want to evaluate? So, let's say I take a thin spherical shell like this. Okay, and that is the main point. Uh, we have to select that element due to which the pressure is exerted on something. So we know that the gravitational force due to Earth is a spherically symmetric thing. At all points at r distance, its value is always same. So it is uh, very convenient, or we can say it is pragmatic, to take that shell where everywhere the force is same. So let's say at some r distance, right, at some dr depth, we want to evaluate what is the pressure exerted by that shell. So we'll say that pressure is dp. We'll say this mass is dm mass, and this g is the gravitational force at that point. So we have to take one point uh, of concern, that we are taking the variable from the center of Earth. The distance is taken from this point O. So whatever value will input in G, it will be in terms of R. So we can say gravitational force divided by the area of this sphere, that is 4 pi r square. That is my excess pressure created by this thin mass. So all we have to do is we have to put the value of G and integrate this. So this is 4 pi r square into dr into rho into G naught into small r by capital R, and divided by 4 pi r square. PR stands for pressure at r depth, at r a distance from the center, and P capital R stands for pressure at the surface of Earth, which is going to be 0. So this value, it comes out to be rho G naught by R, R square minus R square upon 2. So that's it. That's our value the uh, for the value of gravitational pressure at a depth R inside the surface of Earth. So thank you for joining.